I like using that.
Good.
Um, but we were learning about like being able, like, selecting or doing queries from tables and things like that.
Anyone else? How are we feeling about Khan Academy in general?
I feel like for me it was really helpful. I think once I got to SQL Bolt, I got intimidated and I'm like, oh man. But I did just read through and work my way through halfway through.
Good.
I like it. I use it as a student and as a teacher as well, so I like it.
Awesome. Awesome. What's your background when using it, Larry, in other Khan Academy topics or in SQL in itself, or
Other kind of academy topics? So I think I did JavaScript with some of my students at MercyWorks, and then I just use it for like math and things of that nature.
awesome.
Yeah, same. I use it for math too when I was in college.
Awesome. I realized the other day that I don't know how it came up, but long division came up, and I thought, I really do not know if I could divide a number without a calculator. And I had to think about it, and I went, no, I think I still remember how to do long division, but it's had been that long where I had forgotten it. So anyway, yes, Khan Academy is awesome for lots of good topics. Tonight we will be using some documentation that Microsoft has actually provided that I've turned into some slides, but we're going to continue to lean on different resources, both from Microsoft and from Lucidchart, who is a company who's similar to diagrams.net. But anyway, we're going to keep on using outside resources to continue learning SQL. This week, we're going to get a little bit more hands-on with SQL. We're going to install Postgres on our computer tonight. We're going to get a program called Beekeeper Studio set up. Beekeeper Studio is very similar to Postman in that it is the kind of the utility that we use to interact with the database. And then later this week, we will get set up in Node and Express and that kind of stuff. So we're going to take a somewhat different approach to database design this week and try and get database design crunched down as small as possible. We're going to cover all of the theory tonight, which may be a little bit more boring because it's going to be a little bit more slide based. Then we're going to get into ERDs, entity relationship diagrams, which is basically the diagramming language or the diagramming standard that we use in order to design a database. Your homework, one of your homework assignments for this week will be designing an entity relationship diagram for your database, which is basically learning how this database forms, right? How do we go about going through all of the steps? So we've gone through kind of the software development lifecycle, right? Of, hey, we've got to do some requirements planning and we need to figure out, hey, we don't just dive right into code. There are steps before starting a project where we need to identify requirements and kind of go through that process. And then also that just because we're done coding doesn't mean that we're done this whole cycle, right? There's testing steps afterwards, and it is a cycle in that we go in and continue working on our software. So that's kind of the goal of tonight, is to talk about the different steps that we hit during database design and identifying the different information that we need to collect before we dive into creating an entity relationship diagram, which is basically doing all the design work of our database before we get into the actual SQL itself of executing those queries. But the good news is we start a little bit more hands-on tonight, installing both Postgres and Beekeeper Studio, and then we go into more of the database design and theory stuff, which will open us up for the rest of the week in terms of getting hands-on with our database, using both our design and our SQL, and using Node to make our own API. So that is where we are headed. With all of that said, I am going to launch a poll for OpenHack is tomorrow. You guys should be familiar with this poll at this point. For OpenHack, do we want to cancel class tomorrow to give everyone an opportunity to attend OpenHack? Or do we want to keep going with databases and skip for OpenHack? So going to let everyone vote in that poll. I would encourage everyone to go to OpenHack. I think it's a good social opportunity. I think as you continue to learn, it is an opportunity to interact with people of the community and kind of share what you're learning and be in person with your fellow students. So I personally lean into canceling class for OpenHack. I will attend tomorrow. And if you do have questions that pop up, I'm happy to do kind of one-on-one sessions during OpenHack. But want to give everyone that opportunity. We have 8 votes in and 14 students joining, 13 students joining tonight. So hopefully everyone gets an opportunity to vote there. The poll is directly in Zoom. Give everyone one more minute while I go grab my coffee, and then we will make the final decision from there. Hopefully 1 or 2 more people vote because we are, as always, split. I will be right back in 1 second. Okay, sorry about that. Last call to vote. Fortunately, the votes are no longer split, but last call to vote for OpenHack. Okie doke. Just so you guys see, I'm not crazy. Hopefully you can all see the poll results. We were right on that fence, but we did lean into canceling class tomorrow for OpenHack. So no class tomorrow. I will be at OpenHack in person. I believe it starts at 6 o'clock downtown. Same place class is at Common Space Work. If you have any questions, feel free to hit me up. I will say that if you are not able to attend in person, just shoot me a Slack message if you have questions, whether that's questions on your capstone, whether that's questions on catching up on homework, whatever it is. If you have a one-on-one topic that you would like to spend some time on with me tomorrow, feel free to shoot me a Slack message and I'll get back to you on a time during OpenHack that we can jump in a Zoom session. Otherwise, I will be in person for OpenHack tomorrow, and we'll be able to do any of that in person or virtually. Any questions in general about where we're headed in class or anything in general?
No, just a reminder that it's crunch time.
All right, let me get my computer set up here for screen share, and then we will dive right in. Okay, so we are going to start off class with installing both Postgres and Beekeeper Studio. Postgres is the database server that we are using. is the database variant. You may hear it be called. Lots of different SQL servers out there, right? MySQL and Postgres are probably two of the more popular ones. Microsoft SQL or MS SQL and Oracle SQL are two other ones. MariaDB is a version of MySQL. So just in case you hear of these SQL variants, it's important to remember here that these are all SQL-based relational databases, right? So it doesn't matter if we go in and we use Postgres and we learn all about Postgres, and then you go into a job and they're like, oh, we use MS SQL instead. Not to worry, most of that SQL, the syntax and the language does apply. They're just little variations of how that database works under the hood. So if you're reading job descriptions and they say, oh, we use a SQL database, you know that you can apply your everything that you've learned directly into that. And then even if they say, oh, we use what is called a NoSQL or a non-relational database, the most popular one there is called Mongo, but there are a couple other ones. Google has one called Firestore. Even then, those database principles still remain the same. The way you design that database, the way you structure that database may be a little different, but all those database principles still remain, right? Of, hey, the database is there to store our data long-term. The data exists even if we shut down the computer and restart it. That database is still there. So we'll do kind of a general database review tomorrow and talk about what a full web stack is. But today we are going to get hands-on experience getting our database working outside of the web browser. And then we're going to dive into database design, and I'll have some slides for you there. Okay, so to get started, we are going to download Postgres. And we actually are not going to download Postgres from the Postgres community website. Instead, we are going to download something called Postgres App. So if you just do a Google search for it, it will take you to postgresapp.com, and you'll see it's postgres.app. This is a program set up for installing Postgres on the Mac that just makes it really easy to get started. With that said, I also have linked to it in the daily outline for today. If you are someone who normally pulls up the outline, today is a very good day to do that, because I have a whole heck of a lot of links in today's outline. We're going to be going through the slides in a moment, but the postgres.app is linked to right here. And while we're going through these steps, Latonia, who is our TA this week, is going to be building out this steps document that we have going on right here, because we're going to be going through a fair amount of steps tonight. So anyway, I'm going to go to this postgres.app link and pop it open. I am then going to go to the downloads tab right here. And then right here, it says Postgres with Postgres 14 Universal. That is the one that we want to install. So we're going to go ahead and hit the download button on that. And it shouldn't be too huge of a download. So if we click on the DMG, that's what's going to open this. And a common mistake is to just double click on Postgres right here. We do not want to do that. We want to take Postgres and drag it over into the applications folder. And the reason why we do that is we're copying it from that downloaded file into the applications folder where it can properly get all the right permissions to run. So dragging it over from that icon into applications is the actual act that is installing that application on our Mac. So if we go down to Finder and pop open applications and then scroll down to the P section, we should have Postgres in here. So I'm going to go ahead and double click on that. And it's going to say it's downloaded from the internet. Are you sure you want to open it? I'm going to say open. That's okay. And what we have here is just the application that is going to run Postgres for us. We happen to be running Postgres 14. The versioning doesn't matter too much, although it could down the road. But right now, running 14, latest version of Postgres. We're good to go. But before we can start the server, we need to initialize it, right? This is what's doing all of the setup under the hood and getting all the configuration files created for us. So you see it says empty data directory. Well, that's what the initialize button is going to do for us. So I'm going to go ahead and click on that, and it should come up with these icons down here. Now there may be a couple more databases there, or you may not see Hack Upstate. You may see your username there instead. That's great. What we're going for here is to have that running check mark. So I'm not going to launch a poll quite yet, but does anyone have any questions on getting this to the running spot? Is everyone able to go ahead and get it downloaded, initialize it, and get it running?
I do really quick. I got stuck. I'm still on the download page. I just clicked Mac OS. Is there a
Yeah, the download, you're going to want to pull the one from latest release.
Oh, I see what I did wrong. I'm in the SQL.org. I'll get to the one you're on.
Yeah, so I linked to this in the week 16 day one outline. That's this Postgres.app. It is worth mentioning that Postgres.app is different than Postgres itself. So Postgres itself is a server, but this Postgres app makes it very easy for us to install and run the Postgres server. So this Postgres.app is basically giving us a user interface. So instead of having to launch Postgres from the terminal and install it with Brew, we're able to manage everything right inside of here.
Okay, cool. And we did the latest release just to,
Correct. Yep. This download button right here for Postgres with Postgres SQL 14, latest release, universal is the one we want. So just hit that download button right there.
thank you.
My applications doesn't look like yours. It doesn't have those like those 3 circles. Should I change it to a different?
Do you have an initialize button over here? Instead of start, does it say initialize?
No, I don't have any. I don't have any of that.
All right, go ahead and share your screen. Let's see where you're at.
Okay.
Okay, go ahead back to your downloads folder. And okay, it doesn't look like it downloaded. So go back to Chrome, go ahead and click that download button, and then click on that down either one of those.
Oh,
Okay.
Yep, here it is.
Yep.
So
Then go
now
ahead
I take this and put it over here.
You can drag it into that applications folder right there. Yep.
Oh, that's
And now you can close that window.
just,
And in your applications folder, you should now have Postgres. So you have to kind of, I don't like this cover view personally. I would switch it.
I just clicked on it because I wasn't seeing what you saw, but now
I would switch it to that maybe column view.
right. This is what I had it on, and then
Yep.
Okay.
Perfect. And now use this scroll bar right there. Yep. And you should have Postgres right there. Right click on this one for me and move it to the trash.
Yeah.
Yep.
Okay.
And then now you can open the Postgres app, which is right underneath podcast. You got it. And open. And then you're going to initialize. And finally, you're good to go.
Okay. Okay. Thanks.
Okay, everyone have that beautiful running green check mark going on right here.
Yes.
Okay, so we got Postgres running, and now we're like, great. I've got another server running on my computer. I guess it's on a port. What do I do with this? And the answer is right now we can't do anything with this because the database is running kind of on its own in another port. We need some way to be able to communicate with the database. Postgres app is great at getting the database running very easily and setting up the whole server for us. But now we need some client to interact with the server. Just like we use Postman to interact with our API, we are going to use Beekeeper Studio to interact with our Postgres server. Nicole, if it says empty data directory here, over on the right, it should have an initialize button. And as soon as you click initialize, start will get grayed out here, and instead you'll have the databases. And this is, don't ask me why, but this is the universal icon for database. 3 disks kind of stacked on top of each other. What this is trying to represent is that we have one database server that is hosting 3 different databases. So we're going to go on to this next step of connecting in, downloading and using Beekeeper Studio to connect to one of these databases. Okay, so if you are going off the outline for tonight, I have it linked right here to Beekeeper Studio. Or if you just do a search for Beekeeper Studio, the first link, beekeeperstudio.io. Now, before you dive in too deep, if you click this download button, there's this nice yellow Ultimate Edition with a free 14-day trial. Do not click that. Do not download that. Instead, what we want to download is this community edition over here. So the Ultimate Edition is a paid or commercial version of the application that gives you access to like working in a team and different themes and priority support and all things that we don't need. Because we're just getting started with the database, all we need is the Community Edition over here that has everything that we need and more. So if we click on the download button, we're presented with another option, Intel or Apple Silicon. Apple Silicon means that you've got the M1 chip built into your computer. Intel means that you've got a MacBook from a couple years ago, a year or two ago, or before that. So all of the laptops that we gave you guys as students, almost all of them were Apple Silicon versions. If you don't know which one you have for sure, if you go to the Apple up in the top left and go down to About This Mac, you'll see a chip here. And if it starts with the name Apple, that means you have Apple Silicon. If it starts with Intel, that means you've got a slightly older processor built into your Mac. So if you're not sure, again, you can go to the Apple in the top left of your computer, drop down to About This Mac, and it should say Apple M1. I happen to have the M1 Max version of the chip, but if it says Apple, that means you have Apple Silicon. If this chip section starts with Intel, that means that you're on a slightly older Mac that's using an Intel chip instead. So based off of what it says in this Apple About This Mac, like I said, most of the computers that we gave you guys have Apple M1 chips in them. So you would like to download the Apple Silicon version. If you are on a computer that has an Intel chip, go ahead and download this one. Other than that initial download, there shouldn't be many differences between the 2 different versions. So because I'm on an Apple Silicon or an Apple M1 chip, I'm going to go ahead and download that. And I am going to give it a minute, and you should see the download get started here. It's 112 meg, so it shouldn't be too huge. But once it is downloading, we are going to do a similar thing. We click on it, and that's what's going to give us this window here. We are going to take Beekeeper Studio and drag it over to the applications folder. We are then going to close it out, go back into our applications folder in Finder, and pop open Beekeeper Studio right here. It's going to say, hey, this was downloaded from the internet. This is a security check. Are you sure you want to download it? I'm going to go ahead and say open because I definitely want to download it. And we should get to this screen here. So we're going to just pause here and poll and make sure everyone is caught up to this point. So you should have Postgres.app downloaded. You should have Beekeeper Studio downloaded. Both applications should be in your applications folder, not running off of that .dmg file that we downloaded. And you should have Beekeeper Studio open in addition to your Postgres app that says running kind of in the background there. "19 votes in." Going to give everyone just one more minute in case, sorry, 9 votes in, not 19 votes. That coffee may have hit me a little too quickly. Now we're up to 11. Let's see if we can get to 12, and then we will proceed forward here.
Okay. How do we get to this page where it says Beekeeper Studio? We just go into applications and double click on it?
You got it.
Mine doesn't doing that.
You want to share your screen, Christy?
Yes. Oh, yes. Let's see.
Okay, so go ahead and double click on the Beekeeper Studio.
Right here?
Yep. Is it come out of full screen mode? Did it open on your other monitor?
Did it? Let me see. Yep.
There it is.
Wait, so I was so busy looking at your screen that when it popped up on my screen, I just thought I was seeing the same thing. So I don't need to do anything else,
Nope,
right?
you're caught up.
Oh, okay. Okay, thanks.
No problem. I would like to take a minute to appreciate that getting to this step in the program during the first week of downloading and installing 2 applications would have easily have taken the first hour of class, if not more. And we are like flying on it, right? So take a minute to appreciate the fact that we are all much more comfortable on our Macs now. We get downloading applications, installing them, getting developer tools set up, all of that stuff. So that is a major win, and take a pat on the back for that one. Okay, so now that we've got Beekeeper set up, we want to connect into our Postgres database. So we're going to select a connection type here, and Beekeeper Studio connects to all different variants of SQL. But based off of what variant we're using, Beekeeper needs to connect in a little differently. So what we are going to do is pick Postgres as our database type. And the all of this information, it says localhost 5432. That is the default port for Postgres. So if we go into the server settings here, it's telling us, hey, Postgres is already running on 5432. We can't change that because it's already running, but we don't need to. 5432 is the default port. We're not going to conflict with that in any way, so we can let that just be. So what we are going to do is connect in to what I wanted it to do is show us, if we go back to Postgres and go to the introduction, they've got a little bit more details here in terms of how it is configured. So I'm back on postgresapp.com, and we already did step 1, which is download, move to applications folder, and double click. We already initialized, and this configure the path tools, that's an optional step. We don't need to worry about it. But what I care about is down here. It's saying, hey, the host is going to be localhost. And if we look in Beekeeper Studio, they already have localhost typed in for us. And if we look at the port, it already has 5432 in here for the port. So these are all the different pieces of information we need in order to get our client, our database client, connected in so it's talking to our database server. So the next thing it's going to say is user is your system username. Okay, well, if I go to Apple up here at the top, it says log out hack upstate. But I know I can confirm that that is my username because if I go into Postgres, I can see hack upstate right here as the name of the database and also the default username. So whatever your first database is here, it should probably say your name right underneath it. That is what I'm going to type in for the user. So I'm going to type in hack upstate. Yours will likely be a lowercase version of your name. Now,
Hey, Max.
yes.
Does it make a difference if our username like is showing as the third database? Because mine is not showing like the first like yours.
That's
It's switched.
Shown as
That's-
Postgres.
That's fine. It's probably alphabetically sorted.
Oh,
So
Okay.
whatever one here, you should have Postgres template 1 and one other database. That last, whatever your non-Postgres and your non-template 1 is, should be your username. That's what we're going to type in as user over here in Beekeeper Studio.
Okay, thank you.
Okay,
I tested and it's good.
what's that?
I tested and it's good.
Okay, awesome. Now for the password is blank, but the database name is going to be same as the user. So for this default database, we're going to type in exactly the same thing that was typed in as the user. So now if we click this test button, you should see something down here that says connection looks good. Now here's this, oh, hey there, you should upgrade to the Ultimate Edition. They're trying to sell us on something we don't need. You can go ahead and close that out. And so now we're all connected, we're good to go. But before we hit the connect button, I'm going to come down here and I'm going to save the connection as default. Let's call it default database. That's probably more accurate. And I'm going to hit the save button down here. Now, what that's going to do, it's going to save that connection information in for me. So if I double click on this, it's going to automatically go in and connect me to the database. So let me close out of that and show that one more time. When I'm in here, in this save connection, once you've got your username typed in both for the user and the default database, down here, I'm going to say default database. I'm going to hit the save button. That is going to make it appear over and saved here. And you can either double click on it here in order to connect into the database, or you can hit the connect button here, and that will get us into this screen. Okay, now we've got the information schema showing up over here. That's got a whole heck of a lot of information in it. That is everything Postgres is using under the hood. We don't need any of that. So we can go ahead and collapse that down. So we're into this query 1 area here. Shantina, go ahead with your question.
In order to get to the default databases page, I didn't see what to click on the Beekeepers, the main page.
So when you're here,
Yes,
down here, you should have a save connection.
I'm still on that where it's just that one, where when it very first opened. How do I get it to look like this?
Oh, the drop down, it will say pick connection type. You're going to click on that drop down and pick Postgres SQL or Postgres. Is that the screen you're on?
I'm sorry, I'm going back and forth. Give me 1 second.
Sure.
Opened up more windows than I intended to, so now I'm all over the place. So connection type, and then
You're going to pick Postgres.
okay,
And now you should be on this screen.
I am.
And you're just going to do your username and default database. And you're going to get that information from the Postgres.app. Whatever one is not Postgres or template 1 should be your username of the database. And that's what you're going to type in for the user and for the default database.
Okay,
And then you're going to test, and you should get a little pop-up that says connection looks good or something like that. And then final step, you're going to just type in default database in the save connection and hit save.
default database and the save. I'm sorry, I was checking to make sure it said connection. Okay, so at the bottom, save under save connection, do default database.
Yep, or just default or whatever you want to call it.
Okay,
And then finally, you're going to get default database showing up under saved.
yes,
Now you can just double click on that and that should take you into this screen.
thank you. Yes, I'm there. Okay.
Beautiful. Larry, I saw a hand raised and a hand lowered. Do you still have a question?
Nah, I got it now. Thank you.
Beautiful. Okay, So we're into Beekeeper Studio, and now we can actually start using our database, which is kind of cool. So what's the first thing we learned how to do in SQL? In order for our data to be inserted into the database, what do we need to insert that data into?
Create a table or no?
Create table, yeah. So we are going to go ahead and type in create table right in our query. And we're going to create the table, I don't know, let's call it teachers. And that create table is going to need some column types. Now you may be saying, did the homework, I went through Khan Academy, I don't remember this syntax. And that is okay, because what we can do is just type in W3 schools, create table, SQL. And the first thing that's going to pop up is an example that's going to say, hey, create table. Then we type in the table name, and then whatever goes in the parentheses is going to be the column and the data type. And if we need an example of that, we can always scroll down and see, hey, person ID is an int, last name is going to be the data type, all of that stuff. So what we're going to do is we're going to create our teachers table. We're going to say, hey, the table is going to start out with an ID, and the ID is going to be an integer type, and it is going to be the primary key, and it is also going to auto increment. We are then also going to create the teacher's name, and the name is going to be a data type of varchar. And varchar is kind of like text. The only difference is in Postgres, we need to tell it what the length of that field is going to be. So by default, we're going to do 255. 255 is actually the longest string you can put into Postgres. If you're going to use a longer string than that, you're actually going to use the data type of text. We'll get into data types a little bit later in the week as we dive into our object relational map. Okay, that's all we're going to store in our teachers table is an ID and a name. So I'm going to come down here. I'm going to close off this parenthesis here, and I'm going to put in a semicolon at the end. Now, when I come down here and I hit the run button, I see that there is a problem at line 2. Auto increment is not what I want it to be. So I used the wrong syntax. I'm going to do a search for Postgres auto increment primary key. And Postgres uses a slightly different syntax than SQLite did. SQLite used this auto increment key, but instead in SQL, in Postgres, instead of using int, we're going to use the data type of serial. Serial data types are sequential numbers. The numbers are in serial of each other. It goes 1, 2, 3, 4. And so that's how we use a slightly different data type in Postgres. I totally knew that off the top of my head and just wanted to show you guys how we would look up if we ran into a SQL error. Sarcasm there. Okay, so let's hit the run button again. And now it says query 1 of 1, no results, 0 rows affected. Okay, that's kind of weird, but that's okay. We didn't really mean to insert or affect any rows, but now over here in this public schema, in this public folder, there is a table called teachers. And if we double click on that, it says that there's no data in it. But if you notice up here, nice and tiny at the top, it has ID and name varchar. Okay, that's kind of cool, but there's no data in it. Well, that's okay. We just created the table. Of course, there's no data in it. What kind of SQL command or query do we need to run to insert data into that?
Insert.
Insert what?
I don't know, from.
Values.
Insert into, and what's our teacher's name? Teachers. And what we can do is specify, and again, if you need to look up this syntax, you can go back to W3 schools, and in the menu, there will be a insert into command, and that's going to refresh us of that syntax. So we're going to insert into, and I'm going to let the ID be automatically generated for us. So all I need to do is specify the column name in that first set of parentheses. So I'm going to insert into teachers, and the values that I would like to insert into teachers is my name. So I come down here, and if I hit this run button, it says there was a problem. Relationship teachers already exists. Okay, well, when I hit this run button, what it's doing is it's rerunning this whole query here. Remember how we ran into during SQL Boat where we had to hit the run query button? The problem here is that when we just hit this run button, it's going to try and execute everything here. But what it's saying is teachers, that table already exists. So it can't create teachers. So what we can do here instead, of course, we could just delete this or comment it out, or we could just highlight this line of the SQL command. And now notice our button changed a little bit. Now, instead of just saying run, it says run selection. Okay, so I'm going to click run selection, and now it says column Max Matthews does not exist. That is because I believe we need to use single quotes instead. Okay, so now I highlight that line and hit run selection. I see query 1 of 1, no results. Okay, that's fine because we didn't select anything, but now I can see 1 row affected. Okay, that's kind of cool, but how do we know that worked? What happens if we select star from our teachers table? So I'm going to type that in. I'm going to highlight this again, and then I'm going to hit run selection. Sanjay, the reason we use single quotes in Postgres is whenever we're representing a string, it's not like JavaScript where the single quotes and double quotes are interchangeable. In Postgres, whenever we're representing a value, we want to use single quotes instead of double quotes. And so now in my select from teachers, we have our ID 1 and our name, Max Matthews. Now that's cool, but Beekeeper goes a step further. Beekeeper is that user interface tool that we can use. Instead of having to do everything as queries, we can actually just double click on this teachers table, and it's going to show the table for me. I don't have to write that whole select query. I can just double click on teachers, and it shows up here. So what I want you guys to do, I'm going to launch a poll and answer some questions here, but go back to your query, write another insert into so that you're using a different name for the teacher, then double click on the teachers table and make sure you can see 2 of your teachers in here. Larry, go ahead.
Why did you? I know we're not putting in the ID because it's being auto incremented. So why did you put name before values? Just there.
Because if we leave any of the columns out, we need to specify what values are matching with what column name.
Okay. Thank you.
So if we don't put name in here, it automatically assumes that we want to go in the same order of the columns. And so if I tried to run this without the name in here, it would try and create Max Matthews as my ID. But because Max Matthews is not a number serial data type, it's going to be like Max Matthews isn't a valid ID. And so that's why we need to specify if we're going to leave any of our columns out, we do need to use the column syntax in the first parenthesis group. And that is generally considered best practice, just in case your column types changed or anything like that. It's generally considered best practice to use the column names when you are inserting in values. Christy, go ahead.
I just want to know why your colors are different than mine.
I'm just special.
Oh, okay.
No, I'm just kidding. I'm guessing is yours in kind of like a dark theme?
Oh, no, mine is, just so I did, so you see how your name is green?
Yep.
All mine is green and my name is black.
Do you have single quotes instead of double quotes?
Yep.
Go ahead and share your screen. Do you have a semicolon at the end of the create table statement?
Mhm.
Okay, go ahead and share your screen.
It's
I'm
just
out
like-
of guesses.
I'm wondering if it was, I was thinking it might be like a prettier thing. That's what I was gonna ask.
Yeah,
you.
you've got a quote on line 4 that shouldn't be there.
Oh, that would make sense. But my name showed up. Oh, because I did run selection. Okay, okay, yeah, that makes sense. All right, I knew it was something was wrong.
No problem. Tiffany, you're up next.
So my name is showing up black also, but then it says it's a syntax error at or near my last name on line 6. Can I share?
You sure can.
Okay. 1 second.
You've also got a
Does
wicked
anybody-
echo going on.
Yeah.
Oh, I'm so sorry. Let me, you know why? Because I was logged into the Zoom on my phone when class first started. My apologies. I'm leaving now. Okay, so let me see here.
Okay, so you've got backticks instead of single quotes.
Oh, okay.
So in JavaScript, single quotes, double quotes, back quotes almost always mean the same thing. In Postgres, it is going to be more picky. So if you go ahead and highlight line 6 again,
Okay.
now you'll have the ability to run the selection.
Okay. Oh, okay.
And now if you highlight your select star from teachers and run that, you'll be able to see your insert worked.
Thank you.
So now next assignment, and I'm going to create the, I'm going to start the poll right now. Next task is to modify your insert into statement to insert another teacher into your table, and then double click on the teachers over on the left in the sidebar and make sure both of you, the teachers that you have inserted, are working.
Okay. All right. Thank you.
No problem. Nicole, you're up.
All right, for me, in my teacher section on the top, like where there's the ID equals and then the enter value, mine isn't coming up like yours was on there, but I have everything else.
Go ahead and share your screen. Let's take a look.
So you had stuff here, right?
Yep. So go back to your query. And you are inserting into the teachers table, but the table that you had open was teacher. So if you double click on teachers over on the left,
Do I delete it?
well, that's going to take another SQL command. Let's go into the teachers
Oh, okay.
table first.
Okay,
And now if you double click on that,
okay, I'm sorry.
now that's where your data is hiding. So what
Okay.
do we do to undo
second.
that teacher table that we created by accident?
Isn't it just the delete command? 1 second, I'm trying to find my. Yeah, I would think it was a delete command.
It's similar. We delete rows, but what do we do to tables?
I'm not sure, honestly.
We are going to drop the table instead.
Oh, yeah. I do
So
remember that.
the command that you need to run in your SQL is drop table teacher without the S.
Do I need to do that before the select all or after?
No, we're only running specific lines in our SQL, so it doesn't matter what's before or after it. It's only going to run what's selected, or highlighted, I should say. So drop table teacher with a semicolon, and then go ahead and highlight that one line and hit run selection. And that's going to delete your teacher table. So everything is in teachers.
So I can exit out of this now.
Yep, you got it.
All right. Thank you, but I have everything right.
Yep, you're all caught up now.
All right. Thank you.
Okay, Shanjay, you're up next.
So I added into my table, I did a select from after Max Matthews, and then I insert into teacher, same thing, and then I added Latonia.
Yep.
And then I did a select from teachers, But when I ran, it has Latonia, Max, Matthews, Latonia. So what did I do?
So you probably ran the whole script instead of just running that insert again,
Okay.
which is okay. You would use that delete from teachers where ID equals, and then whatever your double is, whether it's me or Latonia, whatever that ID number is, and that would delete out your extra row.
Oh, okay. Thank you.
No problem. So we're starting to learn a little bit, right? Like this is a real database, right? Of if we accidentally run a SQL command twice, we're going to get duplicates in the database, and there is no undo button. Now we need to modify our SQL, whether it was in Nicole's case of deleting out a table by accident, or Strange's case where we had an extra row inserted. Now we need to write more SQL to fix whatever we accidentally ran twice. And that's okay. That's very common. I'm glad that those issues are popping up now, because it does give us practice of saying, okay, let's rerun this SQL, or let's figure out what our delete or our drop table command is, or any of that kind of stuff. Stephanie, go ahead.
Actually, I figured it out. I'm good.
Okay, never
Okay.
mind. Stephanie, do not go ahead.
Max, I have a question.
Yeah, go ahead, Latonia.
Can you just outline the steps again to delete the row versus the whole table? I just want to put it into the notes.
Absolutely, yeah. So if we're in here and I'm in, so I'm going to just copy this teacher's line. I'm going to paste it down here, and I'm going to insert Latonia in here. And I'm going to make sure I'm not hitting the run button, right? I'm going to highlight this line, and I'm going to hit run selection. And now it says one row affected, and I can just reselect my select statement and hit run and see Latonia is now in here. But let's say, hey, Latonia, that's not your full name. I want to delete that out. And I may want to insert something differently. Well, what I'm going to do is I'm going to say delete from teachers, but I'm not going to just semicolon and run it, because that's going to delete every single row in the teacher's table without deleting the table itself, right? Because whenever we delete a table, we really are dropping the table. Okay, but from here, I want to say delete from teachers where, and I have a couple different options here. I could say where the name equals Latonia, but the preferred way of doing it is using the primary key here, because there may be multiple Latonias in my database, right? Not that Latonia would ever be replicated, but I could do this where name equals Latonia. This would work, but the preferred way of deleting anything from the database is using an ID. I don't need to use quotes around that ID because it is a number, but I do need to select this. Before I run it, I'm going to go ahead and run it, and it says one row affected. Now I could just rerun my select, or I could just go into one of these tabs that I have open, and clicking this little search button up at the top is going to update it. So I see that I only have one person in here. Now, the nice thing about Beekeeper is that we can kind of play around with our data and not have to write a SQL query, right? So I'm going to go ahead and insert Latonia back into the database. I'm going to make sure I have the whole command selected and then rerun that. And then let's say I'm going to insert into teachers again. I'm going to do the name, and I'm going to do a value of Max, but instead of Max Matthews, I'm going to do Max Gerlach instead. So I'm going to select that. I'm going to hit run selection. It says that it inserted it. If I go back into my teachers tab, it's not showing it. And that is because I haven't hit this little search button, or down here in the bottom, there's a little refresh. If I hit that refresh button again, now I'm going to see that popped in. Now you notice ID number 2 is missing. That's because we deleted Latonia the first time we inserted her. So because of that, our ID skips one there. That's okay. That's very common in databases. But now we can actually play around with this query up here at the top. We can say we're the name, and now I could type in equals and type in Latonia's name and filter that table down. Or I could say it is like, and if I type in Max here and search, I get no data. Why is it that I'm not showing up? What did we have to do with that like syntax? Does anyone remember?
Percentage
I
signs.
have to put in that percentage sign. That percentage sign is the wild card. That's saying when anything after Max's name match on anything where anything is like Max with anything after it. That's what the percentage sign is doing. So now Latonia is not showing up anymore, even though she's in my table, because I'm able to use this user interface to kind of build out my query. And the cool thing is, if I click on this little, never mind. So we can build out our query without having to write SQL, just like we could go in here and modify this to say where name is like Max percentage sign. And if I highlight that and run that selection, is it just like, there we go. So this select query is running the same exact thing that we built right in where name is like Max. Christy, go ahead.
I don't know if you said this already, but so since we have select from teachers and we can select it, that means we don't have to keep typing it. We can just go back to that, highlight it and run it every time and it'll keep running.
You got it. And there are little keyboard shortcuts here in that drop down. So one keyboard shortcut is if you're in this one and you hit Command Shift Enter, you don't actually have to highlight it. It will only run the command that you are on currently without having that selection. We can also run multiple SQL commands by selecting multiple ones. So if I reran this, it would rerun all three of these insert commands. But that Command Shift Enter is going to be your keyboard shortcut for running whatever command your cursor is currently on. And then Command Enter is going to literally run everything from the top all the way down to the bottom. Okay. Oh, Shantina, go ahead.
And what is the benefit of being able to do a run selection versus a run?
Run is going to run all of the commands that you have typed in here, as opposed to run selection, which is only going to run what you have highlighted, compared to Command Shift Enter, which is run current, which is only going to run the current command that your cursor is on without you having to highlight it.
And why don't we want to run the entire thing each time?
Because we've already created the table teachers. So unlike our Khan Academy, where it's always running from the top to the bottom, our database is persistent, right? And meaning that the data always is going to exist. So once we run this create table command, that is in our database. That table has been created. So if we try and run this create table again, it's going to be like, table already exists, person. Like, what do you want me to do? I can't have two tables with the same name.
Okay, so, and if we do have to do an additional insert into or make any changes, we should just do that like as we keep going down the page, as opposed to going back to where we first started.
Yeah, so now if I'm in here and I'm like, oh, in addition to the teacher, I would like to store their salary as an integer. Now, if I highlight this and try and run the selection, it's like teachers already exists. I can't create a table. And we're like, well, we want this salary to exist. So how would we get around that? There are two different ways we could do it.
Was it an update or something?
The update is for updating a specific row. What's the other command that we might need to use?
Is it like insert again, group by? I don't know.
No, we are going to use the alter table command.
Alter, damn it, yes.
Oh, yeah.
Almost got there, Wayne. So alter table is going to take the table name and then whatever we want to do, whether it's remove or add a column, the new column name and the column type. So down here, we could say alter table teachers, add salary, which is going to be an integer. And if we highlight that and run the selection, it's going to say no rows affected, but query 1 out of 1. So now if we go back into our teachers table, you see what's showing up here is salary. And salary is null. So it's because it doesn't have a value. But if we wanted to, we could go back in and insert, let's update our teachers table and set the salary of equal to $1 million, where the ID is equal to 1. So now if I highlight that and hit run selection, it says no results. But if I go back to my teachers and refresh down here, you can see my salary is $1 million.
Okay, thank you.
Is that close to accurate?
Oh, I wish. I can dream. I just got told today that my roof needs to be replaced in addition to my furnace. So yeah, a $1 million salary right now would really be appreciated.
So I have another
Zach.
quick question.
Zach,
Do
go
you-
ahead, and then Nicole, I'll come
I
back to you.
apologize.
So if we try running everything we've typed so far and it says that we can't create a table because the table already exists, does it stop running the code there, or does
It
it try
does.
to rerun everything else as well?
As soon as it hits an error, it will stop executing. It will not run anything underneath it.
Okay.
Good question. Okay, now Nicole, you're up.
I was gonna say, did you want to make sure that, like, should we be writing all these commands in as you go or not?
No, we're just kind of playing around at this point. Sorry, I should have been more explicit with that. This is
No
just
problem.
this is just trying to take all the knowledge that we had from last week and start to use it in here, with the understanding that this is going to be a little bit more persistent, right? In terms of, once we run that command, there is no undo. And even if we try and rerun all of these commands, that create table isn't going to work anymore. So now we need to, alter our table to include the column information.
Okay, thank you.
No problem.
Max, I have a few quirky questions.
Sure.
Can you comment stuff out in a table, or is it pretty much in? Like, if someone wanted to run the whole program, could they just comment out lines 1 through 4?
Yeah. So if you highlight and hit Command/, it's going to put in our double dashes for us. That may be something we haven't touched on in SQL. Every programming language has different comment out syntax. You may have noticed that in React versus JavaScript versus CSS versus HTML. Some programming languages use a double dash as their single line comment out. And that is what SQL does. I believe you can also do a command/, and that will work for a multi-line comment. Or if you just highlight the lines that you want and hit command/, just like in VS Code, it will comment out those lines for you. So now if I click outside of this and hit the run button, this will not error out, but it would duplicate my information and insert all 3 teachers' names again. So you do want to be really careful when you run your SQL commands of, what am I actually telling Beekeeper to run? Do I want it to run all of this stuff, which is what it will default to? Obviously, it will ignore commented outlines. Or do I want it to just run the current line that I have selected, at which point I would want to use my Command-Shift-Enter? Or do I want to highlight, these 3 things, at which point it would run all 3 of them?
You said it'll duplicate content in there if you run it this way.
Yeah, so like, because I've got inserts into,
Yeah.
inserts here, it would reinsert those teachers.
Okay.
So now I would have duplicates of Max Latonia and Max Sherlock.
Oh, okay. But if you comment out the inserts, then you can still run the others. Okay. Okay. I understand what you're saying.
Yep.
My other question is, you're using caps on these commands, and is that required, or?
It is not required. However, it is, I don't want to say tradition, but in general, whenever you are using SQL syntax, a word that is built into SQL, like insert or delete or select or add or set or where, you want to use all capitals. Whenever it is something that you have made up, like the teacher's table or the name column or the value that we're inserting itself, that you want to do in either lowercase or the case that you want that actual row value to be. So in general, it is preferred to do them all in uppercase if it is a word built into SQL. But again, that is not a requirement of SQL. SQL tends to be case insensitive.
Is it only the simulated tables that run automatically? Like when
Yes.
okay, so we don't have to worry about turning something off or what have you when we're building.
Correct. Running automatically is not going to be a thing that happens anymore. Okay, any other questions on that stuff?
Yeah, I would do. It says there was a problem, column salary of relation teachers does not exist, line 14.
So make sure you've got your alter table teachers add salary int run before you do an insert into or an update into that table.
Okay, thank you.
Doug, go ahead.
Can you one more time explain, like I get Beekeeper Studio is a tool that we can use to run SQL commands on the database. What is Postgres exactly? Is that a tool for creating databases or?
Postgres is our database server. So if we go into Postgres and hit the stop button here, when we go back over into Beekeeper and we're like, hey, select the teachers again, it's like error connection cannot find Postgres. So Postgres is Beekeeper Studio is a client that is connecting in to the Postgres server that we happen to be running on our local host. So think about when we start up React, we do npm run start and something thinks about it and it goes, great, localhost 3000 is ready to go. And then when we go into our browser and we go to localhost 3000, we're connecting into our React server that is serving up our React code for us. Beekeeper Studio is connecting into the Postgres server we are running in Postgres App. So when we hit the start button here, it is starting Postgres on 5432. So in Beekeeper Studio, when we run that selection, we are able to see the results. So Postgres server is what's actually managing all of the data for us. It's what's storing and executing our SQL commands. But if we're in Chrome and we go to localhost 5432, it's like page isn't working, didn't send any data. Well, that's because Postgres server is not a web server. It isn't serving up some HTML and CSS and JavaScript. It is instead expecting a SQL client to connect to it. So just because we get this page isn't working in 5432, that's because it's not a web server. Postgres is a SQL server. So the only way we can connect to it is using a SQL client like Beekeeper Studio. So we're going to connect to port 5432 on Wednesday, not only using Beekeeper Studio, but directly in our node code. We will be using an npm package that knows how to use port 5432 to execute SQL commands and retrieve the results of that.
And so is Postgres what we use to run a server that's serving the database?
Yes.
And would we do that in practice, or is it just for testing locally?
You would do that in practice. We happen to be using Postgres App as an easy way to get our Postgres server running. On an actual production server, you would be using the terminal to set up a Postgres SQL server that you would have your databases within that server.
Okay, so is the Postgres app just for tooling around, or
It is just for tooling around, although a lot of people would use that in tandem with a production database, and they would sync the data between the two of them. So when Nathan Evans comes back in, I'm going to say 4 weeks, it might be 5, what he's going to do is take all of this full stack code that you have learned to write on your local computer, and he's going to show you how to deploy that to a company called Heroku, and Heroku is going to host your Postgres SQL server and databases for you, in addition to your backend node code and your front end that you're building in React.
okay, wow. One last question.
Sure.
Where did those databases come from that show up in the Postgres app?
By default, it will always create one with your username, one called Postgres, which is like the system database used for maintaining information about your databases. And I'm not really quite sure what template 1 is, to be honest with you. But when we dive in on Wednesday, we are going to create and connect to a different database name, and we will have a different database for each one of the projects we're working with.
Okay, thank you.
No problem. Any other questions? Okay, I am about to seriously bore you when we get back with database design, but I don't want to dive into that for 15 minutes and then have to take a break. So let's take our break a little early and be back at 7:05. You might want to get some coffee or something that will help you stay focused, because there is no other way for me to teach this database design stuff. I tried really, really hard to make it interactive, but was not able to get there. So we're going to have some slides to go through when we get back. We'll cover the database design principles, and then we will dive in actually hands-on with entity relationship diagrams and using diagrams.net for what it was actually built to be used for. Break. See you guys at 7:05. And I'll stick around for a minute in case anyone has questions. No, Nicole, you don't get the extra minute. 7:05. I was muted. Okay, so first things first, this is largely based off of an article Microsoft wrote. It's probably a 15-20 minute read. I would encourage everyone to read that if you are someone who learns well by just reading. I broke this up into slides just so I can talk to them a little bit better, but the main source of my of the content here is from Microsoft. And I just want to mention that, one, from a plagiarism perspective, two, from also a, if you are someone who learns better by reading, you can go check the article out there directly. And then the other thing is that they actually created this for Microsoft Access. And Microsoft Access was a very interesting product because it kind of shot for the prosumer level. It shot for someone who was a little bit more of a professional computer user, but still in the consumer space. And Access was unfortunately a product that never really took off. It was so that a regular average person could use a database without having to dive into the terminal or understand how servers works or all of that stuff. But the reason why I am mentioning that is any relational database shares these database design principles. So whether you're using a tool like Access, whether you're using SQL directly, whether it is MySQL or Postgres, they all kind of fall into that same category of, hey, database design is something that you need to think through before you just jump in and start using the database. So with all of that said, we're going to go over a couple terms, and then we'll get into the key concepts for tonight. So table has rows and columns. Think of a table as a traditional spreadsheet. There may be a few columns, but an unlimited number of rows. And that's a really important thing to keep in your head here. Of some tables may have 20, 30, 40 columns, but they could have millions and millions of rows. And so something to keep in mind there. And then most databases will have one table, more than one table. It's very rare for a single database just to have one table in it. You may hear me say a field in that table. What I mean there is just a column. And of course, in SQL, the fields or columns have specific data types. And then every row represents a single item in the database, right? So if we've got a table called products, what is supposed to be represented in that row is a single product. And while that may seem like common sense, when you're designing out your table, you may be working on an order and you're typing in the customer's information into that order. And that should be a red flag, right? To say, wait, this is information about the customer, not information about this specific order. Should I design my database a little bit differently there? So like I said, this is going to be pretty dry. I'm sorry, I couldn't find any way to make this more engaging than a lecture. But the idea here is that we get the basic database design rules communicated to you guys so that you understand it. And then second half of tonight, we'll dive into making an entity relationship diagram, which is when we start actually using these database design principles to start laying out what our database looks like visually. So good database design. Good database design divides your information into subject-based tables, right? So, hey, if I am running a place that has orders and customers and inventory, all of those would get their own separate table names. When we think about that, an orders table, that makes sense, right? Oh, I'm going to store the date of the order, maybe the total amount of the order. But when we start thinking about our database design, we want to break that down to reduce redundant data. So if I have an orders table, what if a customer comes back and orders from me multiple times? Well, now I need to start storing their name every time that they place an order. We are now causing redundant or duplicated data. So a better table design there would be to separate out your customers in your orders. So just like we practiced with left outer joins and pulling information from two tables, instead what we would do is in the orders table, we would store the ID of the customer so that we can store one row with the customer's information, multiple rows of their orders, and be able to overlap that data without having to duplicate it all in the customer's table. So good database design is all about joining that data together, right? Joining tables together as we need. It helps support and ensure the accuracy and integrity of our information. What that's saying there is saying, hey, when we need to update our customers' information, instead of having to update every time they've placed an order, all of those rows, we're able to go into the database once and update that information. That means that when we go into our users table or our customers table, we can ensure that data is accurate, as opposed to, hey, what happens when they change their address on the one order? Does that mean it's going to update on all of their other orders? And then finally, database has to be useful, right? It needs to accommodate data processing and reporting needs. It needs to be able to be easily updated, and it also needs to be able to easily pull that information out. Okay, so designing a database, we break it down into these basic steps, right? Think software development lifecycle here for the database. So instead of speaking directly to developing a new piece of software, which ironically or interestingly enough, choosing a database is part or can be part of the software development lifecycle. But when we get into the database itself, we go through these basic steps. So we determine the purpose of the database. We need to find and organize the information required. We need to know what kind of information is getting stored in this database. We then break down that information into separate tables. We take that information and identify the different columns that are in those tables. We then specify primary keys. Primary keys are crucial and so that we can relate data together and so that the database can keep track of our data. We then set up table relationships. We're going to go into one-to-one, one-to-many, and many-to-many relationships and how we identify them. Then we refine the design through testing. And then finally, we make sure that all three of our normalization rules are applied. If you do not fall asleep during the normalization rules, I will be very, very impressed. All three of those are kind of like make your eyes gloss over. But when you do wrap your head around them, it's kind of like when you learn to do something and you're like, yes, but why do we do it like that? It makes sense, but why? The three normalization rules are like three rules or laws of physics, right? It's like, this is the explanation of why we do things the way we do in the database in terms of making sure that we're not duplicating things or having things structured properly. They are very boring. However, we will save those for last before we dive into our entity relationship diagram. Any questions on any of that? I know that all of that's kind of boring, but does all that make sense?
To a degree.
Okay, we're going to go into each one of those steps step by step to break it down a little further. So first step was determining the purpose, right? So purpose here can be a sentence or a paragraph or a couple of bullet points, right? So for capstone project, right, Christie's initial idea, the basic point of the database could be something to say, collect different bike routes and organize them in a way that we can easily create new ones and keep track of comments and users and who has ridden those routes. Something as simple as that, right? If we were running an appliance repair shop, our repair shop could say, keep track of customers, ongoing repair orders, and billing information, right? Something basic here, but we also want to identify who's going to use it because we need to say, hey, the person doing the repair is going to use this database a lot differently than the person who is talking to the customer and logging that repair information in, who is going to use it very differently than the customer itself, who may want to check on the repair status or review an estimate cost or something like that. So defining the mission statement just makes it easier throughout the design process to focus on our goals and make decisions. Because when we start structuring our table, we may run into a question, and having that mission statement predefined makes it easier to go back in there. Any questions on that? Okay. So finding and organizing the required info. This is often the most intimidating step. And the one where we need to rely on some existing process, right? So chances are there is some process that already exists here. That process may be on paper, right? It may have forms that the customer is filling out. That may be word of mouth. That may be the company is just passing this information along and saying, hey, you know, this person is now working on it. When you're done, hand it over or pass it into the inventory system or whatever it is. So chances are data already exists in this flow that we are trying to capture. So important to take a step back and examine the business process. Who is involved in this data? Who inserts the data? Who is updating the data? And what do you want to show them on a page? Use existing forms, use either existing collected content, just identify out what information needs to be stored. That's your starting point. And so the place that I normally start is I brainstorm. Just throw everything at me. What information do we need to store here? We don't need to get this perfect, right? We've already practiced with the alter table command. As we're developing our app, we'll find that there are additional fields that we need to add. We may forget about entire tables, but what we want to think about first is, what is that output? Where does this information show up? And if we can determine where that information shows up, it makes it much easier for us to make sure that we've got all of that data accounted for. Then the other thing that we want to do is break down the data as much as possible. Can anyone think about the differences between just storing name in one field as opposed to storing first name, last name, and title? Can anyone think about why we would want to store it broken down, or what maybe some of the consequences of that might be?
If you want to sort it alphabetically by first name or last name, if you don't have them separated, you might not get as accurate as a result.
Sort is a great example. Can anyone think of anything else? So let's say I want to send an email out to all of my customers, and I've got email address stored in the database. And now I say, oh, I want to say, good morning, first name here. How's it going today? We were running a special, right? Well, if we've got name all in one field, and I write, dear or good morning, first customer name, it's going to sound really weird to say, hello, Max Matthews, right? We don't address people by their full name when we write a letter. And we wouldn't say, hello, Mr. Max. We would say, hello, Max, or hello, Mr. Matthews. And when we've got that data broken down to that level, it makes it much easier. Now, you may say, well, there's a space separating their name, so why don't we just break it out that way? Well, look at Latonia. Latonia has two first names, right? And so how do we know where there are two spaces in the name separating out three names, whether or not that's going to their first name or going to their last name? So you can run into some really bad situations where you're addressing someone by their first last name, but forgetting their second last name. Or you get into some weird cases with hyphenation, right? Where all of this may sound so trivial now, but when your database grows to millions of rows, and now you want to actually go work with that data, you can really get tripped up in not having the data broken down into those separate fields. So thinking through all of that in your database design, really important step to do now, so that you're not shooting yourself in the foot down the road by not having that data broken out. Okay, so from there, we can move on to the next step of the process, which is dividing the information into tables. So first step is we need to identify the major entities or subjects. So in this situation, we're using customers, products, suppliers, and orders. And this seems so trivial, but being able to identify where your tables are, what your different table names are, makes it much easier to start breaking down that entity relationship diagram, figuring out what your tables need to be. So let's say, hey, we're going to start out, and it may make sense that the products and suppliers are all in the same table, right? We're just going to create a table called products. And now we run into this situation where, oh, well, we are storing information about the supplier on every single product. We're storing their name, the contact name, the supplier address, and the supplier city, state, and zip. Okay, well, now what happens when we update that? If we're associating that with every single product, we need to update that information on every single product to make sure that when the supplier has moved or when we get a different contact person, now we need to update multiple rows. That's less than ideal. What other consequences could we run into if we stored duplicated data? For example, if we stored that supplier information in every single row, every single product that they supplied us.
Misspelling.
Yep, we run into misspelling. We run into now having to update multiple rows of info. What else could we run into? Kind of have the. Go ahead, Nicole.
Duplicate of like data, like maybe you put one in one spot and not the other spot, so now you're looking in the wrong spot. I do that often.
Absolutely. Yeah. Or if we run a query, now we've got a ton of information for every single product coming back about the supplier, right? We only really need that supplier's information once. So yeah, we run into a lot of different problems there.
Hey, Nick, I have a question before you move on.
Yeah, go ahead.
It sounded like you were going to transition. Should we be worried about bloat in our databases?
Absolutely.
Like,
Yeah.
is that
So
an issue?
yeah, it just takes more storage space, right? And when you think, oh, well, it's just a couple letters of text, it's not going to be any big deal. Well, what happens if that supplier provides 10,000 products to you? Well, now you're storing their address and contact and phone number and all of that stuff on 10,000 rows, when really all we want to do is represent, hey, this product comes from this supplier. And if you need the supplier's information, go do a join on the supply table, on the suppliers table. So what we do is we use our relational database to our benefit here. But what we want to do is we want to say, hey, we want to store information in the table that the fact or the data is about. So, hey, this supplier's address, yes, it relates to the product, and we need to know what supplier is providing this product, but is this supplier's address really about the product, or is it about something else? And whenever it becomes about something else, that's when we say, hey, we'll worry about this table relationship in a moment, but because it is about something else, we should create a separate table for it. And that's how we kind of get down into this orders, products, customers, suppliers, and separate out the information there. Now, obviously, not every database we design is going to have these table names. These are just the principles of separating out the data. Any questions on that? I know a lot of this sounds like common sense, but when you are working on your capstone ERD, and I give you guys feedback on that, and I go, no, this should be a separate table. And you go, yeah, but why should it be a separate table? We can come back to these slides and actually find that bullet point and go, well, this is separate, or think about the duplicated data here, or is this information really about the table that we're storing it in? Okay, go ahead.
Oh, I'm sorry. What other hints do you have around organizing that content? Like, what if it's just not clear what table it should be in?
So
will it be? Maybe it's a silly question. Maybe it will be clear. I don't know.
Yeah, so one technique you can do is say, well, I'm not entirely sure that this data should be here, but I don't have any other place for it to go. And so I'm going to put it in that table. I'm going to just work with it as a hypothesis. And then one of the last steps in this process is insert some test data. Actually start playing around with it, right? Because yeah, the table structures are great, but what really matters is the rows, the data actually going into the database. So sometimes when you start playing around with it, just like we did in Beekeeper Studio today, right? Where we inserted the teacher and then we were like, oh, salary, let's alter the table and add that in. Or, hey, let's insert some data and see if that makes sense. Oftentimes, your table structure it is not fully complete until you start inserting your data. And that's when you start recognizing, hey, I'm inserting some things in here that aren't really about, the product. Maybe I do need a separate suppliers table, or, hey, I do have a lot of duplicated data in here. How can I create another table to de-duplicate that information? So oftentimes you don't know what the right answer is until the data actually starts going in there. Okay, so next step is we've got our tables identified. Now we start breaking it out and start getting down into the column information. So what columns would we use to store an address?
Street.
Address / ID.
State.
Yep. So we're saying city, state, maybe zip code, street address, and now we get into a little hairy spot with street address of, well, what happens if they have an apartment number? Okay, so now we need a street address too. Now we need to be careful there because we could go even further. we could say, hey, we're going to break it down to house number, street name, and street type, right? Road, street, avenue, highway, all of that different stuff. But now you got to be careful and you go, but do I need it broken down to that level? At any point, will I need to address this user by their street number and not their street name? And so that's where we get careful in our database design, and we start going, all right, we don't really want to drive the user crazy by having them enter their street number and their street name and their street type. We're just going to have one field called address one, and that's where they're going to enter all of that information, right? And so oftentimes we can even rely on other people's database design and say, well, how does Amazon take address, right? Because if Amazon has the fields broken down that certain way, that's probably going to be enough in our database to store it that way as well. So now we run into an interesting position of, hey, my business is doing great. It's really taken off. What happens if we now have someone place an order from the UK? So now we get into this interesting spot of, well, the UK doesn't have a zip code. They have a postal code. And that postal code isn't all numbers. Their postal code has letters in it. So now we get into an interesting spot of saying, well, do we modify the table to be able to store a postal code in addition to the zip code? Or do we identify that international orders are going to be stored in a separate table with separate columns? There are pros and cons to both approaches. If you're saying, hey, I have very few international orders, so what I'm going to do is I'm going to give the user, when they're checking out, an option to change their order type from the US to a different country. Well, when I do that, that's going to show them different database fields in the form. That's going to show, that's going to store in a different table, and I can have different column types. That is one approach, and that works fine. The other approach you can take is say, well, I'm just going to add more columns onto my one table. I'm going to have a postal code column in addition to my zip code column, but my postal code column is going to take letters. It's going to be a string because postal codes may have some letters in it. And if it's not an international order, that column will just be null. We won't put any data into it. Pros and cons to both approaches. At that point, you need to go back to your requirements and say, well, what percentage of my orders are going to be international? If 99% of my orders are going to be based in the US, it makes sense to put my international orders in another table where I don't need to store null fields for all of those other columns. But if there is a good chance my orders will be a good mix of international orders, maybe I do mix those two tables together and just determine what columns I'm going to store the data in based off of what country the user has inputted. So other general rules of thumb when we are doing database design, we never store calculated data. What is an example of calculated data that we might be tempted to store in our database, say if we were working on an orders table?
The total of the purchase.
Bingo. That is the most common mistake of calculated data stored in the database, because we think, oh, the total, throw that in the database and we're good to go. But now what happens when an item gets added to that order? Now we need to recalculate the total. So instead, best practice is every time we need the total, just go look at all of the items in that order and use a sum query in our SQL command to add up all of those item prices to figure out what the total of that order should be. So in general, we never store calculated data in the database because the database can run a sum query or whatever other piece of calculation you need to do so quickly that it is better to not store calculated information. And then the last part there is store information in the smallest logical parts. So that's already what we talked about, right? Of breaking down, hey, your address shouldn't really be one field in the database. We should have address 1, address 2, city, state, and zip, and each one of those will be separate columns. I have seen some people even go as far of saying we aren't going to store city and state in the database because we can calculate that off of your zip code, which is an interesting approach. It's one that is not often taken, but it is taking that rule to an extreme. Any questions there?
Why is that considered extreme? Is that more expensive to do it that way?
It's not necessarily more expensive, but there are some weird quirkiness things with zip code where sometimes just because your zip code comes back. So oddly enough, my zip code, even though 95% of my zip code is in Manlius, there is 5% of my zip code that is in Cazenovia. And so when you type in the zip code, I always expect Manlius to come up, but sometimes I get a drop down that's like, oh, are you in the Manlius part of this zip code, or are you in the Cazenovia part of the zip code? And so a lot of people will want to type in their city and override what the default value comes back as their zip code. So city and state aren't always a 1-for-1 match to what your zip code is. And that's why normally you store city and state and let the user type it in. Okay, so moving on to primary keys. We've already been exposed to primary keys a little bit when we use our create table command. Primary keys are how the database keeps track of each individual row. So we normally auto-generate this in our SQL using auto-increment or something similar to auto-increment. In SQL, it is almost always a sequential integer number. It is possible to use other columns as primary keys. However, it's pretty rare. In general, whenever we create a new table in SQL, the vast majority of the time, we're going to create an ID column that is used as the primary key. But the reason we use primary keys is that so we can relate data together, right? So we can reference a product ID and reference that on the orders table and know that, hey, when we're talking about product ID in the orders table, that relates to the primary key, the primary ID in the products table. So primary keys can never be duplicated. So we can never have 2 rows with the same ID. If we do try and do that, that insert command will fail and it will say, hey, this ID already exists. You can't create another row with that ID. Where else have we seen keys in the curriculum already?
Foreign key.
Foreign key we're going to get to in 1 second. I'm thinking of another example. Where else have we touched on keys?
With objects.
With objects, yep. And object keys need to be unique, right? We cannot have 2 of the same key and an object. I was thinking of one more place that we use keys that is a little bit closer to a primary key.
Array indexes.
Array indexes when we are mapping in React. So when we map in React, you know that really annoying error that comes up that says, hey, we're looping over something. Please add the prop key to your return of your map. That is the same principle of a primary key in SQL. So the point of putting a key on that item in React is so that React can keep track of that thing that came out of the map. So if that data gets updated, React knows to only update that data for that particular key. The same goes for SQL. When we say, hey, update teachers where ID equals 1, we're using that ID primary key to identify that specific row, which makes it easier to update that data. So primary keys sound very boring. Frankly, most of databases are probably sound boring, but primary keys are basically just saying, hey, whenever we create a table, we traditionally add another ID column. That ID is an auto-incrementing number. It is a sequential number, and we use that ID in order to be able to update our data. Okay, so table relations. This is all about, we keep on talking about a relational database. We keep on saying SQL, all SQL databases are relational databases. It is basically just saying, hey, how do these tables relate together? How does the orders table that is storing product ID relate to the products table? How does that information overlap, and how can we join it together? So we just touched on the primary key. The primary key is the unique identifier for a row and a column. We also have foreign keys. Foreign keys are literally whenever we reference a primary key in another table, right? So, hey, the orders table is storing a product ID. Product ID in the orders table is a foreign key referencing the primary key in the products table. So whenever we are referencing the ID that's unique for that row, that is the primary key. Whenever we use that ID in another table to connect the data back together, that is when it becomes a foreign key. So several different kinds of table relations. The most common is a one-to-many relationship. So a teacher may have multiple students. So the primary key in the teachers table is the ID, but that table, that primary key is used as a foreign key over in the students table, right? So our teachers table has 3 columns, an ID, a first name, and a last name. Our students table has an ID, a teacher ID, a student first name, and a student last name. So instead of storing teacher, first name, teacher, last name, all in the students table, we are able to instead use a foreign key, teacher ID, that is referencing the same ID over here. So if we wanted to find all the students of Testy McTesterson as a teacher, we would be able to do an left inner join to be able to take ID 3 and match ID 3 over with teacher ID 3 here and see that Mario is a student of Testy McTesterson as a teacher. Does that make sense? We can have one teacher over here who may have many students over here. So teachers would be on the one side and students would be on the many side. Now, a one-to-many is also implied in the reverse. The way this data is set up is that a student may only have one teacher, which is why we say it is a one-to-many relationship. One teacher may have many students. Okay, next type is a many-to-many relationship, right? So let's think about an order. An order may have many products, but one product may be included on many orders. So this means we have a many-to-many relationship, which is what is called an anti-pattern in database design. Whenever we have many-to-many data relationships in SQL, we actually need to create a third table, which is called a bridge table, that pertains only to the information in the order. So every order is going to get an order ID and a customer ID. And we're going to have our products table, and that has a product ID and a bunch of product names. But what we do is we use this order details table to bridge the information between the order itself and the product information. So what we do is we say, hey, order ID 10248 actually has 3 different products in it. That is referencing 1142 and 72. But what it is doing is product ID is relating to the products table, and it is also relating to the order table. So these 2 tables are not directly related, but because we are going through this bridge in the center, we are able to represent, hey, order ID 10248, which we are referencing up here. We know that anytime we've got a row in order details, it is all going to reference WILMK as the customer. but 11, 42, 72 are all the product IDs. So that is going to relate to these 3 products here. Any questions on a many-to-many relationship or how or when we would use a bridge table? Okay. So finally, we've got one-to-one relationships. This is probably the most infrequent kind of table relationship that we use. Normally because it doesn't break any database design rules. Let's say you have a customers table and you want to store some address information about that. Well, you could just put that right in the customers table. You don't need to create a separate table for customer address and link them together with customer ID. Sometimes it makes sense if there's some infrequently collected information about them. The example we already ran into is foreign address. So we may store their address about them in the customers table normally, but if they do have a foreign address that has some additional fields that aren't frequently used, we could create a customer's foreign address table and relate those two together and say, hey, every customer will also have a row in the foreign address table, and we will link those two together with the customer ID. Make sense? Told you guys this was really boring. Good news is we're on slide 14 of 17 already. Okay, so once we get through relating the data, we're kind of over halfway through our database design step. So now once we think we've got a draft of our database design structure, that means we've got our table names or entities figured out. That means that we've got our columns in place. That means we have already identified how this data relates together. Now we start loading in some dummy data. We start running some insert into queries and start running into, oh, hey, I am accidentally duplicating customer address in 2 different tables. So maybe I need to go in and modify my design. You can always go in and modify your columns. However, it is always better to do that before you actually have users in the software. The example we ran into tonight was, hey, we decided that we wanted to store the teacher's salary information, right? So we altered our table, we put the salary column in there. We think everything's fine, and now we get a report from our user that's saying, hey, I'm running a report, I'm running payroll here, and I keep on getting cannot read null of undefined on teacher ID 2. We're like, users certainly shouldn't be getting that. And so we go back and we look at it. Well, it turns out we added a new salary column, but we only added the salary to 1 person in the database. Now, when we insert new rows, yeah, we know to insert salary information, but what about all the rows that already existed in the database? So for that reason, it's better to identify that sooner rather than later. And whenever we add columns, it's a good idea to go back into our existing data set and say, hey, are we already dealing? Are we updating our rows to insert that salary information? And if we're not, are we prepared for null values to come back? Are we prepared essentially when we query that table for the teacher not to have salary information in there? And do we handle that in our report as well? So something to think about. But once we get to this point, we get to kind of do some checks, right? So we say, hey, did we get all the columns? Are we able to go back to that first step where we collected the forms of what data got inserted into the database? And are we making sure that all of that data is getting captured? Did we miss an entire table, which is surprisingly easy to do, right? Are any of our columns unnecessary because they're calculated? Hey, the paper form that we're going off of had a total on it, so we just instinctively added a total column, but we catch ourselves there and go, hey, we don't actually need a total because that can be calculated. Are we duplicating any information across 2 different tables? Are we able to identify, hey, we're storing things in 2 places, we should pick one or the other and make sure that that data is related? Do we have any tables with lots of columns and very few rows? If so, can we architect that a little bit better? Can we make it so because the database is optimized for storing millions and millions of rows, but a relatively small number of columns, can we change that data so that we're storing that a little bit better? Is it broken down into the smallest parts? Are we storing address as one big string instead of breaking that out into city, state, zip, all of that stuff? Does each column relate to the table subject or the table name, right? Did we find, oh, accidentally we're storing the student's information in the teacher's table? Ideally, we need to break that out and have a separate students table for that. And are all the relationships represented? Did we make sure to call out, hey, we're getting information about the teacher from the students table, so we want to make sure that that primary key and foreign key are identified. Okay, so in this situation, we have a orders table. What is wrong with setting up our orders table like this? We've got two separate problems. How would we go about, what are the problems in the first place? Nicole, you're really breaking up. It's hard to hear you.
I think she said 2 product IDs.
Yeah, so we've got 2 product IDs here. What's wrong with 2 product IDs?
What's right about 2 product IDs?
Sometimes
well, I can
we don't have
store
new product.
Exactly. Yeah. So
3 products.
order ID 3 right here only has 1 product on it. So now we've got a null value. Well, what happens if I have someone order 3 products on a single order? Well, I could create a product ID 3 column, but now we're literally saying, hey, you can only order as many products as I have columns. So what would be the solution in this situation so that we could say, hey, an order may have many products on it?
Bridge table?
A bridge table. So what we do is we actually break this out and we say, hey, the orders table is really just going to have an order ID. And we're going to have our products table just like we had in the last example, but now we've got an order items. And that order items is going to create a new row for every product that gets ordered on that ID. So we can now say, hey, order ID 1 has 2 products on it. It's got product ID 5 and it's got product ID 2 on it. So now we can go to our products and say, oh, order ID 1 is ordering soap and shampoo. But order ID 2 only has 1 product. It is only 15. So order ID 2 is literally only ordering conditioner. So by using this order items bridge table, we're able to pull information from the orders and also pull information from the products. So we are able to have as many products on the order as we would like, or as few items on the order as we would like. Does that make sense? Whenever we're storing many things, whenever we have a many-to-many relationship, hey, we can have many orders, and those many orders may have many products on them. We need to implement that third table. So now we can say, hey, for every order, there may be many products in the order items table. And for those products, there may be many products that relate to the one product in the table. So instead of that many to many, we kind of break it down and we say 1 to many here in the order ID, and then we say many to 1 in the product ID. We're going to find a way to model that out in our entity relationship diagrams coming up next. Okay. Last thing, normalization. I told you guys this is the most boring of it all. I know you're saying, Max, how can it get any boring than all the slides we just went through? but normalization, other than the first normalization form, is one of those things that you just have to read through 14 different times, and the 15th time you read it, something clicks and it makes sense. So I will attempt to explain this as much as I can, but the first normal form says every row and column intersection exists a single value, never a list of values. In other words, we cannot store an array in our database. When we are looking at our data, we can't say product IDs here and say 5, 2, 3. Every single row and column, no matter what one it is, needs to represent one single value. A value in the database cannot have multiple pieces of information stored in it. Cannot be an array, it cannot be a list. If it is, we need to set up a second table and break that out into a one-to-many relationship. That is what the first normal form is saying, is no storing lists in our database unless you are using a one-to-many relationship with a couple tables. Okay, second normal form. This is where it gets like, you have to break down every word, saying each non-key. What do they mean by non-key? They're saying each non-primary key value. So anything that is not a key column in your database is fully dependent on the entire primary key. Okay, that makes no sense until you get into an example. So what we're doing is we're saying, okay, if a table is storing order ID and product ID, those are our two primary keys. Product name, however, is not a primary key because, or a foreign key, because product ID is referencing something in another table, and order ID is also referencing something in another table. So because these two keys are referencing something in another table, product name is not. So the product name must be removed because it is only dependent on the product ID. In other words, if the product ID changes, the product name also changes. But if we change the order ID, the product name does not change. So this rule, the second normal form, is saying we should not be storing product name in this table because it is dependent on product ID, but it is not dependent on the order ID. In other words, if we change product ID, we need to change product name, but we do not need to change order ID, and that is why product name should not be stored here. If you do not understand these, that is okay. This is a really weird thing where you go, yes, but Max, why can't I just put product name into my bridge table? And this rule is explaining why you are breaking a rule or a law of normalization. Finally, the third normal form is saying not only does every non-key column must be dependent on the entire primary key, but non-key columns should be stored independent of each other. In other words, if we store product ID, name, final price, and discount, okay, well, if we try to update the discount without updating the final price, we break some normalization. So let's say we've got the final price on the order is $100. And now we go in and we say, oh, we want to apply a discount to that order. We're going to apply a 20% discount. Well, we can't apply that discount without also having to update the final price. So because of that, we are breaking the third normal form. And the answer to this is actually we shouldn't be storing the final price of the order. We should only be storing the discount because we can calculate the final price. So these rules of normalization are like the laws of physics. When you say, Max, why can't I design my database this way? You can come back to these three forms of normalization and say, hey, you're technically breaking one of these normalization forms, so you should change the way you are architecting your data. Christy, I'm afraid of what question you may have, but I will try to answer it. Go ahead.
Why? So I'm just thinking about when when we do like the joins and all of that stuff. So before we even get to the joins, this is how it needed to be set up. And then before we even get to the point where we're joining or what's the other one where you put it on top of each other? Well, whatever that is, combining.
Yep.
It has to be set up this way, and then that way it can be combined to the others, but you still follow these rules. Okay.
Correct. So we run into a nasty situation with our joins in this table of, well, depending on how many product IDs I have, I may need to join, 4 or 5 times with the product table. And I don't really know. I have to do another join every time we add another product ID 3, ID 4, or whatever. But this is breaking one of the 3 rules of database normalization. So if we structure the data this way instead, what we are able to do is join the orders table with the products table with the order items table. And if we join those 3 tables together, no matter how many times I have a row in order items, I've done my 3 table joins. So I could have 50 items on the table, but because we're joining the data together and have it structured properly, I only need to do the 3 table joins to get these 3 together. But in this setup, I would have to join every time I have a different product ID. So this breaks a rule of data normalization. This does not. So that is why, because it is structured properly, we can do our database joins as intended. This will make a little bit more sense as we get into our entity relationship diagrams, because we're going to start using these principles in practice to actually lay out our tables. Doug, go ahead with your question.
Yeah, can you go back to the slide with the 3 rules? So the second one, each non-key column is fully dependent on the entire primary key. Could you explain that a little bit? Because I was thinking of the primary key as the unique ID for rows in that table, whereas the order ID and product ID are references to IDs in another table, in other tables.
Yes. So both order ID and product ID would be foreign keys. However, you can do what is called a combined foreign key. I'm sorry, a combined primary key. So it is possible in SQL to say, hey, instead of creating a order items ID, I am instead going to use the order ID and the product ID as the primary key for this table. So in other words, I'm not going to create an ID in order items. I'm only going to use order ID and product ID. And if I combine those 2 together, they will be unique. There will never be another row with the same ID and the same product ID, in other words. So when you do some of your database design, this isn't particularly common, but it is possible to say, I'm not going to put an ID on this table, and my primary key is going to be my order ID plus my product ID. And if we take both of those together, that is going to be the new primary key. So they are saying, if you do that, and for whatever reason, you had another column on here called product name, that would break the second rule of normalization, because you wouldn't be able to update just the product ID without making the product name also go out of sync.
Okay, I think that makes a little more sense. Thank you.
Good, because I am just at that level of grasping it myself. These are not the rules of normalization. If these are one thing that it's okay not to get, because when you are doing your database design, you're going to say, hey, I have my customer's address stored in the orders table and in the customers table. I don't know what rule of normalization I'm breaking, but that ain't normal. So let me go fix it. And that is kind of the common sense of normalization, is basically don't duplicate your data and make sure that you can't possibly update your data in one table and make it fall out of sync anywhere else. If you are able to do that, you have not normalized out your data. And these are kind of the three rules where if you do understand these forms of normalization, you are able to say with certainty, hey, this is set up the right way. But this is one of those things you just have to read it over and over again. And sometimes coming up with an example yourself just in a spreadsheet is able to help you understand what those three forms of normalization are. Zach, go ahead with your question.
Kind of a two-part question. So for the first normalization form, that's basically saying, like, on the previous slide, you wouldn't want to have the product idea of like 2, 5, 15, right?
You got it.
And then second part of the question, so like for that same form, if you were to add like multiple products to the order, like, is that one item 4, I think, have a value of 20 because it's shampoo and conditioner? Or is there another item that's just not visible on the table?
I just forgot. I ran out of space to put that in here.
Well, how would you show multiple different order items in the same order then?
So right here, we did order ID is 1, and this is also 1, but the product ID is 5 and 2. So what we're saying is order ID 1 has products of shampoo and soap in that order.
Oh, okay. Thank you.
Very good question. And this is the reason the bridge table is why we need to, the bridge table is the solution to the first normal form, right? Of every row and column exists a single value, never a list of values. Well, in a database, it makes sense that we want to store a list of that data, right? And so the naive approach is, well, then I'll just make columns for every product that I add to the order. But that is actually breaking the second normal form, in that if we update a product ID here, this product ID might not make sense anymore. So instead, what we do is we take this, and even though this is technically not breaking the first form of normalization, this solves the product better. This solves the problem better because it allows us to have a one-to-many relationship between our products and our order items. We are able to say, hey, there may be any number of products on a single order, and there may be any number of orders that have many items on them. So what we're able to do is say, for every order, one order, there may be many items on the order. And for that one product, that is going to tie into our products table down here. So we're breaking a many-to-many relationship into a one-to-many, and then a many-to-one relationship between the orders and the products table. And that's what the bridge is doing, is it's connecting those two tables together without breaking the first rule of normalization, which is we can't store a list of those things.
Okay, thank you.
Again, hopefully that makes more sense to you than it does to me, because these rules of normalization are one thing that it just, for me, it makes more sense to use them in practice than it does to understand what the rule itself is saying. And if I find a good YouTube video explaining the 3 rules of normalization, I will share that out in the Slack channel and add that to the outline tonight, because I am very, very confident that I can find someone who can explain normalization better than I can. Okay, we made it to the end of my super boring slides that I'm probably legally, contractually obligated to teach. If you can't tell, database design is not my favorite topic, but what is my favorite topic is getting into full stack app development, which we get to start on Wednesday after OpenHack. So that is what I am super excited about. But Nicole, you misread my enthusiasm for thinking we are done for the evening. We still have ERDs to cover. Yay, entity relationship diagrams. So the good news is you do not need to listen to me going through entity relationship diagrams. Instead, we get to watch a short video about entity relationship diagrams. So this is how we practice our database design. This is how we kind of work through our database design using standard diagrams so that we can understand how our database is designed. So this is actually what diagrams.net is good for. I know there is mixed feelings about diagrams.net, but that's because we were kind of pushing it to its limits as a mock-up or wireframing tool. Entity relationship diagrams are where it excels. I will say that this YouTube video is put out by Lucid Software, who makes software called Lucidchart. It is using the same open source software that diagrams.net uses. Lucidchart is just a paid commercial version of diagrams.net with some additional features in there as well. But for copyright reasons, I'm actually going to pause the recording. So if you do want to watch this video as part of the YouTube videos, it is linked in the outline. But I need to reshare my screen with sharing sound, and then we will watch this video.
Hi, my name's Taylor and I'm from Lucidchart. We'll be learning all about entity relationship diagrams, or ERDs. We're going to start off by discussing a high-level overview, and then together we'll dive in and build an example together, complete with entities, attributes, relationships, and cardinality. By the end of this video, you'll be able to build an entire entity relationship diagram from scratch. Have you ever...
Me too, the image is still.
I think you're still recording too.
Thank you for the reminder. So we're going to do a quick, literally in 5 minutes or less, we're going to dive back into diagrams.net. We're going to create our very basic entity relationship diagram. And then we will watch the part 2 video on Wednesday. Review anything in entity relationship diagrams that we need to touch on. And then we are going to get hands-on into our node. So again, homework assignment is to start designing out your ERD for your capstone. Start identifying what fields you're going to need in your database, and the entity relationship diagram is just going to be kind of your middle step between actually diving in, creating the database, creating the tables, starting to insert rows into it. This entity relationship diagram just sets you up so that your tables are structured properly. So I'm headed into diagrams.net. We go all the way back to this feedback app. Yes, it shows you how much I am using diagrams.net. So I'm going to go to File, New, up here, up at the top. And instead of creating blank diagram, I'm going to pick entity relationship diagram here. It's in the second row for me, and I'm going to hit Create. If you want to follow along with this, you can. If you don't want to, I completely understand. So they've actually already created this for me, but this is a step too far for me, right? So I'm just going to select it all by dragging and hit Delete. So I've got a nice blank canvas. And then over here, instead of going into general, I'm going to collapse general and go down to an entity relationship. And what that's going to do is that's going to give me this nice table set up here. So if I drag this out, I get my first entity, right? And an entity is just representing a table. So what I'm going to do is I'm going to say, hey, I'm going to start with my teachers. And my teachers have a primary key of teacher ID. Now, what else did we say was on our teachers? We said the teacher's first name and let's say last name. And then if I don't want row 3 to show up here, I can just single select it and hit Delete. And I actually need to get it on the other side, and that will delete it out for me. So I can now come back over here, pull out my next diagram, and I'm going to say students. And my students are going to have a student ID, and that is also going to store first name, last name, but it's also going to store teacher ID. So to relate these two together, I can take my teacher ID and grab this line here and drag it over to my teacher ID here. Okay, but now we need to get the cardinality set up, right? So we can say, hey, what is the relationship between the teachers and the students? So what we want to do is, for this one in particular, we want to say that the teacher, there is only going to be one teacher, but they can have many students. So on the student side, we are going to put that crow's foot. Oh, wrong side.
Click that again. Oh, okay, never mind. See it.
Why can I not?
Try the one that says none.
Yeah, it's probably going to be that one. There we go. And then on this side, we are going to say 1. 1.
I think it's the one under that is 1. Yeah.
There we go. Okay. So what we're doing is we're starting to set this up, and we're starting to say, hey, there can be many students for one teacher. So we start building out our entity relationship diagram. And as we're working on that, we can actually go into that export tool, if I can remember where it is, and we can actually get the SQL command that's going to create those tables for us. Export as, forget where that is in diagrams.net. Anyway, we will pick it up there on Wednesday after OpenHack. I just need to remember where they put that SQL thing, but I will find that and we will pick it up here. I just wanted to show diagrams.net, show you that you can get started on your ERDs. But if you want to wait, we are going to spend a little bit more time on our ERDs before we move into actually using our database hands-on. Any questions for tonight? Make sense? Super boring class? Excited to get hands-on?
Yeah.
Awesome.
I think it makes sense. Time will tell.
Go ahead, Christy.
I was just saying it wasn't boring. I feel like it was calm, relaxed, peaceful.
Yeah, this is always a tough thing to teach because there's no real hands-on way to say like, hey, let's pause and practice using that third form of normalization on the database. You know, like there's no easy way of doing that. But the fun part now is that we've got all the SQL basics down that we need to in order to start using these concepts, right? So now we start getting back into Node and start setting up our API server, and then we start layering in our SQL and getting practice with that. So I know in the curriculum, it says that we are in database design for the rest of the week. However, we will kind of go into Node and then full stack and then come full circle back into our SQL stuff. So the curriculum timing gets a little messed up there because all of these topics are interrelated. But I have taught it this way for the 2 other cohorts. And this is the way that all the puzzle pieces start to come together the best. So we will take that same approach. Start getting into Node, start getting into full stack again, go back to the chat app, layer in our SQL, and then layer in some advanced concepts like an object relational map or an ORM. So that's where we're headed. That's all I got for tonight.
Max, should I should I post this link for them to do the survey? Are you all doing that daily, or is it a weekly thing, or?
It's optional at this point. If you've got feedback, feel free to fill it out. Tony can post a link, and it's in Canvas as always. But if you want to save it up and kind of do it at the end of the week, that's also fine.
I just tried to find that, and I can't find it, how you export it the way he did it. But the other ones work fine. I mean, I've used it a number of times. The other ones work fine also. They just won't build the tables for you, obviously, but so maybe if you Google it.
Yeah, I wonder. You have to install the plugin for it.
Oh, okay.
So you edit that and then go to, I seem to remember this. Plugins, add, SQL, okay, apply. And now if you refresh and okay, and edit, now you should get I'll play with it and let you guys know.